Okay, so for this video, we are going to talk about the 5 different types of chemical reactions and how to predict the products of each type of reaction. Okay, so for the purposes of this course anyway, we are going to consider that there are 5 types of chemical reactions. Now there are different classifications. You may see 4, you may see 6 types, but we're going to go with 5. Alright, so the first type of reactions that we want to talk about is called synthesis. So in a synthesis reaction, okay, you have 2 or more substances that are going to come together to make a single product. So it's going to look something like this. Okay, we're going to have some element, A, react with another element, B, to form a single compound, a new substance. We're going to call AB, since it's the 2 elements now combined together. Okay, so synthesis comes from the word synthesize, which is just basically creating something. And it's going to be 2 individual substances coming together to make a single product. So an example would be if you had potassium metal reacting with iodine. Okay? So if this is a synthesis reaction, then we know we're going to have K and I coming together, right? The only thing we're left to do is figure out the subscripts. We know we're going to have potassium iodide, we just need to figure out how many potassium, how many iodine. Okay? So let's just do some scratch work over here. The charge on potassium, if we look at the periodic table, is a +1. The charge on iodine, since it's a halogen, is a -1. So we notice that we don't need subscripts. Okay? We're good just like that, Ki. Now we just need to balance the equation. So to do that, we would put a 2 here and a 2 there, and we're balanced. So there's your basic example of a synthesis reaction. What I want to do now, I'm going to give you a couple examples. After I give you the examples, pause the video, and then I will go over them. So, first example. Let's say we have zinc metal reacting with fluorine gas, and I want you to try to predict the product, okay, based on the 2 ions, write the right subscripts, and then balance the equation. So pause the video now. Alright, so zinc and chlorine are going to come together, so we know we're going to have Z and Cl in some form. Alright, now zinc is tricky for this transition, but it is a 2+ ion, always. That's what it is. Chlorine, halogen, 1-. So that means we're going to need 2 of those chlorine ions to balance out the 1 zinc. So it's going to be Z and Cl2. Nice thing about this one is it's already balanced, so we're good there. Okay, let's try another one. Let's do Ca, calcium, reacting with oxygen. So pause it and then I'll go over it. Alright, so we know we're going to have CaO. We're going to come together, calcium oxide. So let's look at the ions over here. Calcium's a 2+, oxygen's a 2-. Okay, if we were to crisscross, we would get Ca2O2. But you don't want that. Remember, you always reduce it to the simplest. So we really just need 1 of each, CaO. And to balance, we just need to do that. Okay. So, the other thing you might need to do is recognize that if I were to give you words. So if I were to say aluminum metal reacts with bromine, okay, you would need to write the entire reaction. So think about it, pause it right now, and come back and check your answer. Okay, so we have aluminum metal reacting with bromine. Okay, and this is probably going to have tripped some of you up right here. Bromine is a halogen. It's one of the diatomic elements, so it's actually Br2. Okay, that's how it occurs naturally. And it's going to produce, it's going to be aluminum bromide. We just got to figure out the coefficient. So Al is a +3, bromine is a negative, so that means we have AlBr3. This is one of those where we have to find the LCM. So the LCM of 2 and 3 is 6. So we put that there, and there to give us 6. Put that there to balance the aluminum, and we're good to go. So those are your basic synthesis reactions. If you can do those, you should be okay as far as that's concerned. So the next type I want to go over is called decomposition. Okay, in a decomposition reaction, you start out with one product, or one reactant, I'm sorry. Okay, we'll call it compound AB. And it's going to decompose into separate products. So it's basically the opposite of synthesis. One reactant decomposes into two products. So an easy example is water. If you run an electric current through it, which you can actually do at home with a D battery and a couple wires, and you can produce hydrogen and oxygen gas. It's pretty cool. So if I were to not give you this product, and you just had this, well, you could probably figure out that it's going to be hydrogen and oxygen. That's the only way for it to decompose, right? So you can fill that in. However, you probably run it like this to start out with. But we're back to that diatomic thing again. Hydrogen and oxygen are both diatomic elements, so they're going to exist like that. Which means we're going to need to do that to balance it. Okay, so that's what a decomposition reaction looks like. Let's try another one. Let's try copper oxide decomposing. So pause it and give it a shot. Come back and check your answer. Okay, so it's going to decompose into copper and oxygen. We know that much. Okay. Oxygen's diatomic, so it's going to be like that. Now we need to balance, and we're good. So that's all you need to do for that one. It's really not that bad. Let's try one more decomp. Let's do let's do iron, chloride. So pause it and give it a shot. Alright, so iron's a metal, it exists by itself. Chlorine, again, diatomic. So to balance, put a few there, a few there, a few there, and we're good to go. Those are your basic decomposition reactions right there, something breaking down. Simple enough, you're probably familiar with the word decompose. Alright, the next type is what's called single replacement reactions. Okay, you might see it called single displacement. Really means the same thing. Those are just used interchangeably. So in this type of reaction, you have an element, we'll call it A, reacting with a compound, which we'll call BC. Okay, and we're just going to do a single replacement. So one element is switching places with one other element. Okay, so we're going to end up with B plus AC. So you see A just kicked out B, basically. So an example of that would be, and we did this in class, magnesium reacting with hydrochloric acid. Okay, so we know something's going to replace something. First step is figure out what is replacing what. Okay, And the way to do that is, look at the charges. So magnesium is a positive ion, it's a cation. Hydrogen here, positive, cation. And chlorine is an anion. So what that means is, magnesium is not going to want to go bond with hydrogen. They're both positive. That's not how the electromagnetic forces work. Magnesium is interested in bonding with chlorine, right? Positive and negative. So that means, fix my writing here, that means magnesium is going to replace hydrogen. So we're going to have magnesium chloride, and hydrogen's going to be by itself. Okay, and now we look at subscripts. So magnesium and chlorine. Magnesium is a 2+ unearthed metal. Chlorine is a -1 halogen. So it's actually going to need to be MgCl2. Hydrogen, again, is diatomic. So it's going to come out like that. So hydrogen gas is produced, which is why you saw the bubbling when we did the reaction in class, which is also why there was a little flamethrower thing whenever I lit it on fire. Okay, now to balance, all we need to do is add a 2 there. Okay, so that's your basic single replacement reaction. I'm going to give you 3 examples. I want you to pause it, try all of them, and then come back and look for the solutions. So first one, let's do lithium. It's going to react with sodium chloride. For the second one, or for the next one, I'm sorry, let's do chlorine gas is going to react with sodium bromide. Okay. And for the last one, let's do zinc reacts with hydrochloric acid, which is just HCl, if you didn't remember. So go ahead and pause it, give those a shot, and then I'll come back and do the solutions. All right, first one. Lithium is your positive ion, so it's going to be replacing sodium, the other positive ion. Okay, so that means we're going to have Li and Cl now together. Na is alone. Okay, we look at charges. Lithium is a +1, chlorine is a -1, so we're good there. And sodium is cool by itself. All right, so let's look at the next reaction. And by the way, the first one is already balanced as well, so we're good there. For the next one, okay, chlorine is a negative ion, sodium is positive, bromine is negative. So that means chlorine is going to be replacing bromine, the other negative ion. So we'll have bromine by itself and sodium and chlorine go together. Notice I'm ignoring the original subscripts. I don't care that it was Cl2 to start out with. Okay? I'm just writing Cl for now, and we're going to figure out what the eventual subscript is going to be. Okay? So, bromine, diatomic molecule, Br2. Okay, we look at Na and Cl. Na is a +1, Cl is a -1, so we don't need subscripts there. We do, however, need to balance, but that'll do the trick. Okay, for the last one, we have zinc reacting with hydrochloric acid. Okay, so this is a single replacement. Zinc is going to replace hydrogen, the other positive ion. Hydrogen is going to be by itself, and we're going to use chloride. Okay, so hydrogen's diatomic, 2 there. Zinc has a +2 charge. Chlorine's got a -1, so that means it's actually going to need to be Z and Cl2. Okay, So that's your single replacement reactions. If you still have trouble, go find some more examples, but that's the basics right there. We have two more types left. So, double replacement. Okay, in a double replacement reaction, the general form is you have a compound AB reacting with another compound, CD. And it's just going to be a double swap, basically. So you're going to have AB and BC. And yes, I realize those are time periods, but, you know, I digress. So, an easy example. We'll start easy. We have salt, sodium chloride, reacting with lithium fluoride. Okay? So, first step is figure out what switches with what. So we're going to label them positive and negative. All right? Positive switches with positive, negative switches with negative. Okay? Stopping against Na is not going to be paired with F. Fluorine. Lithium is now paired with fluorine. Okay? And be careful not to write, you don't want to write FNA or ClLi. You always write the metal first. Okay? Always write the metal first. It does not matter at all which order you write these two. But it does matter which order you write these two. You got to write the metal first and the compound name. That goes back to our nomenclature rules that we talked about. Okay, so we have swapped our ions. Now we look at charges. And we see that we do not need subscripts or to balance the equation. Already balanced. So let's do a couple more slightly more difficult examples. Let's say we have, let's do potassium sulfate reacting with barium chloride. Okay. So, tell you what, I'm going to give you three. You got lead nitrate, potassium iodide. Again, predict the product, write the balanced equation. And last but not least, let's do hydrochloric acid and potassium hydroxide. So pause it, give them a shot, come back for the solutions. Alright, so first one. We have potassium sulfate and barium chloride. So switch them up. Positive and positive we're going to switch. So we're going to have, let me go back to black. We're going to have potassium chloride. And again, I'm ignoring subscripts right now. We're going to come back to it. Barium sulfate. Okay, so let's look at charges now of the products. Potassium is a +1, chlorine is a -1, so no subscripts needed there. Barium is a 2+. Sulfate, if you look at your polyatomic ion sheet, which, you know, you only need that if you haven't memorized them yet. Sulfate is -2, so no subscripts needed there either. So that was nice. We do need to balance the equation. To do that, all we're going to have to do, a couple quick steps here, and I think we're good. It appears to be balanced. Okay, so next one, lead nitrate and potassium iodide. We've done this one before. Fix my ugly number there. All right. The product, if we switch them, is going to be potassium with nitrate. Remember, nitrate stays together, it's an ion in and of itself. And we've got lead iodide. Alright, so let's look at charges now. Potassium is a +1, nitrate is a -1. No subscript necessary. lead. Okay, lead is one of those that falls under the transition metal rule where you don't know the charge by looking at the periodic table. So we're going to have to look back at the reactants. So if we look back here, we've got 2 nitrates to balance out 1 lead. If each nitrate's a -1, that means lead must be a +2. So that means lead is a +2 over here. We know iodine's a -1. So it's got to be PbI2. Okay, so there's our equation there. We just need to balance. So to balance it, you put a 2 there and a 2 there. Okay, last one. Hydrochloric acid reacts with potassium hydroxide. Okay. Let's switch them up here. We have K and Cl, and we have H and OH. Okay, so let's look at our coefficients here and our subscripts. Okay, and OH is a -1, so no subscripts necessary. The only other thing that I would do to simplify this equation a little bit is rewrite HOH. So I'm much more familiar H2O. Okay, and as you'll learn later on, when you mix an acid and a base, you always make salt and water. And we will get to that later on in the year. All right, guys. Again, that's it for double replacement. If you're still having trouble, go find more examples. There are plenty out there on the internet. Last type of reaction is called combustion. So, rather than give you a general form for combustion, I'm just going to tell you, in the combustion reaction, you have a substance added to oxygen. Some substance is added to oxygen, and heat and light are produced. Okay, when we say heat and light, this basically just means fire. That's all fire is, right? Heat and light. Just a bunch of energy being given off. So, we'll do a few examples of combustion. Okay, you have, let's say we have magnesium and oxygen. Okay, notice this looks a lot like synthesis because you have 2 different elements being added together. And technically, this one would fall under the guidelines of synthesis, which is why I told you earlier there are a few different classifications of reactions. But anyway, if you see that something's being added to oxygen, you know it's combustion. Combustion is the answer there. So, when you add those together, you're just going to get MgO. And like we found out earlier, no subscripts needed. We do need to balance though. So there's one example of a combustion reaction. Okay. The other type, and this is a nice rule to know, let's say we have methane burning. Okay. This is a little bit trickier if you're not sure where to go. But the nice thing is, if you have an organic molecule, okay, some hydrocarbon. Okay, you see something with C like this, CH4, okay, methane. If you have ethane, propane, any of those alkanes, anything with carbon really, if it burns, the products are always going to be carbon dioxide and water. That's a great rule to remember. If you're burning an organic molecule, the products are carbon dioxide and water. Organic meaning containing carbon. Okay, so we do need to balance. So we're going to need to do a little bit of that, but the products are going to be carbon dioxide and water. So I'm going to give you guys a few examples here, and then we're going to be done. Let's say we have sodium metal burns. and we're going to burn some glucose. Okay, we're going to add heat. We're going to add a lot of heat here. This is not going to be a spontaneous, bursting into flame. And we're going to do iron. All right, so give it a shot. Try to balance them. All right, so the first one, we put Na and M together. Now, if we look at the charges, we have positive 1 and negative 2, so we'll actually need 2 sodium atoms there, which means we'll need a 2 here, 2 there. So we'll go back here, clean this up a little bit. Okay, so that one is now balanced. Next one, okay. First tip, we see carbon here. So that means our products are going to be carbon dioxide and water. Really nice. Doesn't matter. It could be C 1000, H 2000, O 1000. Doesn't matter. The products are going to be carbon dioxide and water. That one will just be nasty to balance. Okay, to balance this, let's look at carbon first. You got 6 on the reactant side, so let's put 6 over here. Okay, now carbon's good. We have 12 hydrogen on the reactant side, so we'll make there be 12 on the product side. Okay, oxygen, we currently have 2 on the reactant side, and we currently have, 18 on the reactant side. So, I'm sorry, no. Yeah, 8 on the reactant side, 18 on the product side. So to fix this, we'll have to put a 6 in front of this oxygen. Okay, so that's combustion of glucose. The last one, iron and oxygen reacting. It's going to make iron oxide. Okay. I know this is a really tricky one. Probably shouldn't have given you this one, because iron can be in the +2 or +3 state. So I feel bad now, but it's going to be one of these 2 options. And it just depends on which form iron takes. Okay? Just depends on which form iron takes. So you would not get that one on a test. Not in my class anyway. Okay, so that's it for types of reactions and predicting the products. If you're still having trouble, there's a lot out there, so just go look for more practice. It's definitely there.